at deductive reasoning and conditional statements in 2.3. So when we talked, guys, stop talking, please. When we talked about inductive reasoning in 2.1 and 2.2, that was like using patterns or examples and things to draw conclusions. Deductive reasoning, we said, is using facts and definitions and properties, which it says here, you're using given fact, definitions, and properties when you do deductive reasoning. So it's the process of using logic to draw conclusions, okay? The process of using logic to draw conclusions from given facts, definitions, and properties. Okay, so that's deductive reasoning as opposed to inductive. Inductive used patterns and like examples. So we're going to practice identifying, is it an inductive reasoning or a deductive reasoning that these conclusions were drawn from? Okay, so the first one says, at Bay High School, students must take biology before they take chemistry. Okay, so this is a given. This is a rule at that school. Sam is in chemistry. So Courtney concludes he has taken biology. Okay, so because this Sam is in chemistry, Courtney thinks he must have already taken biology because of this rule at their school. So for her drawing that conclusion, do you think that's inductive or deductive? Inductive uses patterns. Deductive uses facts, definitions, rules, things like that. So what do y'all think? Say it again. Deductive, very good. So that one used deductive. So I'm going to put here up at the top if you AI. Oh, perfect. Thank you. If you want to add this where we have inductive and deductive to help as a reminder, inductive is using patterns. Okay. Deductive is using fact. Okay, so she used the fact that they have to take biology before chemistry to make to draw her conclusion. So yes, that one was deductive reasoning. Okay, and the next one, it says all the students in Mrs. John's geometry class are sophomores. Chris takes geometry but has another teacher. Mrs. John concludes that Chris is a sophomore. Okay, so she is using, to draw her conclusion that Chris is a sophomore, she is using what she knows about her own class. Okay, so her own class is all sophomores. Does that mean it's a rule you have to be a sophomore to be in geometry? No, she's just using her own experience, the example or the pattern in her class. So what type of reasoning is that? If she is using what she has experienced or the example from her classes, that's inductive reasoning. Because it's not a rule that you have to be a sophomore to be in geometry. That's just the pattern established in her classes. She happens to have all sophomores. So she concluded that this kid in a different geometry class must also be a sophomore, which maybe he is, but he doesn't have to be. Okay. But she used, that's inductive reasoning. Okay, this next one says the sum of angle measurement of a triangle is 180 degrees. Okay, that's always true. Okay, we know the three angles of a triangle add to 180. Two angles of a triangle measure 40 degrees and 60 degrees. So Kendall concludes that the third angle measure is an 80-degree angle. What do 40 plus 60 add to? 100. Okay, and we know that the sum of all three has to be 180. So she concluded that that third one must be 80. What reasoning did she use? Was that deductive or inductive? That was deductive. She was using the fact that all three angles have to add to 180. Okay. A detective learns that her main suspect was out of town the day of the crime. She concludes that the suspect is innocent. That deductive or inductive reasoning? What do you think? Is it a what? Yeah, she learns that he is out of town. That's a fact. He is out of town. So yes, that is deductive because she used the fact that he was out of town. Mm-hmm. Do we kind of understand the difference in deductive versus inductive? Yeah. Okay. Now, conditional statement. This is a new term. Okay, it's pretty important. We kind of touched on it in 2.2. We said if P, then Q. Okay, so let's define a conditional statement. So a conditional statement is a statement that can be written in the form if P, then Q. And this is the symbolism that we use. We use lowercase p and q, and then there's an arrow from P to Q. So the way that we read this is if P, then Q. Okay, so that's how we read that. If P, then Q. Now, the part that, the P, okay, the part that comes after the if is what we call the hypothesis. Okay, so the hypothesis, and then the part that comes after the word then, okay, the Q part here, that's called the conclusion. We touched on that in the 2.2 notes. Okay, so you have an if then statement, that's called a conditional statement. Okay, and it's if P, then Q. Okay, it has the hypothesis is the P, the conclusion is the Q. Okay, so let's practice just identifying. In these statements, the hypothesis we're going to underline and the conclusion we're going to circle. Okay, so the hypothesis is after if. I don't actually even have to read this to be able to underline what comes after the if. Okay, and then circle what comes after the then, because that's the conclusion. Okay, now looking at those statements, when you are given a conditional statement, you are going to want to be able to say whether it's true or false. Okay, so just because it's written doesn't mean it's true. Okay, so if you live in El Paso, then you live in Texas. Okay, that's true. Now, maybe there's another El Paso in a different state or country that I don't know about. So I guess technically this could be false if you knew about that other El Paso. I don't. So I'm going to just say that this is true. And for some reason, when y'all's notes printed, this part here, now determine if each is true. Okay, if it's false, give a counter example. Didn't print right here, it printed on the back, like in a weird spot. Okay, so you can find that on the back is this next part, determine if it's true. If it's false, give a counter example. I don't know why it like jumbled. I apologize. Okay, but on the, so you might have to flip yours over to the back to find this part. But I would say that this is true because the only El Paso I know about is in West Texas. So if you are in El Paso, you are in Texas. Okay. Now the next one says, if an angle is obtuse, then it has a measure of 100. Now, can that be true? Is a 100-degree angle an obtuse angle? Yes. Okay, obtuse, remember, means bigger than 90, less than 180. So between 90 and 180. But does that mean every obtuse angle is exactly 100 degrees? No. Okay. So this is false because it's not true all the time. It can be true, but it's not true all the time, or it's not the only truth. So we have to provide a counterexample. Okay. If it's false, give a counterexample. And we said back in 2.2, we said a counterexample, or maybe it was in 2.1, I don't remember. The counterexample is what proves it wrong. Okay. We're proving it wrong. Okay. So what is an angle that's not 100, but is still obtuse? Can somebody just tell me an angle measure? Obtuse is more than 90, but less than 180. So somebody tell me a number that falls in that range. More than 90, less than 180. 95, good. So a 95-degree angle would be a counterexample to that conditional statement. Okay, because 95 is not 100, but it's still obtuse. If you need to put in parentheses, obtuse is between 90 and 180. Okay, put that in parentheses so you remember that. Okay, that last one says, if today is Monday, then tomorrow is Tuesday. Is that true or false? That's true. That's always true. If today is Monday, tomorrow is Tuesday. We never skip Tuesday, do we? No. So this will always be true. So I don't need to put a counterexample. I only need to give a counterexample if the statement is false. I'm showing an example of when that statement is false. Does that make sense? Okay. Then we are going to learn about some different ways that we can rearrange our conditional statements. Okay, that P and that Q, that hypothesis and conclusion. Okay. Sometimes this gets confusing, but there is symbolism for all of these. So when you negate something, that means like you do the opposite. Okay, it's like the negative of it. Okay, so to negate a statement, okay, the negation of P would simply be not P. Okay, that's the negation of P. Now the symbol is this little tilde, this little squiggle. Okay, so a tilde P means not P. The negation of the statement M is the midpoint of segment AB would be M is not the midpoint of segment AB. Okay, you're just stating the opposite. Okay, you're making it a not statement. Y'all follow? That's called negation. Okay, so negation means not. Okay, now our conditional statement starts out as if P, then Q, right? That's our hypothesis and our conclusion. Okay, so one of the things that you're going to need to be able to write or identify is called the converse. The converse of a conditional statement is exchanging the hypothesis and conclusion. So notice in the symbols, instead of if P then Q, now it says if Q then P. You want to put that in words, if Q then P. That's the converse. You just switch the order of Q and P. You switch the hypothesis and conclusion. Now, the inverse is the negation. You're negating both the hypothesis and the conclusion. So notice they put the little squiggle, the little tilde in front of P and Q, but kept it in the original order. So this would be read, if not P, then not Q. And then last but not least, we need to be able to give the contrapositive. The contrapositive is a combination of both the converse and the inverse. It's formed by both exchanging and negating the hypothesis and conclusion. So you switch the order and you put the not. So this would be if not Q, then not P. Okay. And again, I know sometimes, especially when we're first learning this, it can get confusing. So make sure you understand the symbols. Okay. So if you start your conditional statement is if P, then Q, switching the order is converse, negating is inverse, doing both is the contrapositive. Okay. Now, when we do this, okay, you'll notice if a conditional statement, maybe it's true, maybe it's a true conditional statement, but then when you create some of these converse, inverse, contrapositive statements, it may no longer be true. And that's okay. Okay, it's not going to stay true all the time. Okay, so let's try this. Yes, quickly, please. Okay, so we're given a piece of information. All elephants are mammals. We want to put this in if-then form. We want to make it a conditional statement and then find the converse, inverse, and contrapositive. Okay, so first we're going to rewrite it in if-then form. Okay, so if it is an elephant, then it is a mammal. Would y'all think that's a good conditional statement for all elephants are mammals? What they're saying is if, let me get black. It is an elephant, then it is a mammal. That's what this means, right? All elephants are mammals. So if it is an elephant, then it is a mammal. So I just put it in if-then form. And if you want to put the symbol out here, if P, then Q. If P, then Q. So it is an elephant. That's my hypothesis. It is a mammal. That's my conclusion. So the converse says to switch the order. So we're going to go if Q, then P. So I'm just going to switch what I underlined in green and blue. So I'm going to write if it is a mammal, then it is an elephant. So I put my Q at the beginning and my P at the end. So I switched it, Q, then P. Now, is that one true? No. See, when we switched it, it's no longer true. Okay, if it is an elephant, then it is a mammal. That's true. But if it is a mammal, doesn't mean it has to be an elephant, right? So that's false. Okay, now the inverse, remember the inverse, we just negate P and Q. We keep it in the original order. P is the hypothesis, Q is the conclusion. but we negate, we put the not, we put the opposite of what it said. So it's going to be if it is not an elephant, then it is not a mammal. So I kept the P and the Q in the original order, but added that word not. I negated both of them. So I did, if not P, then not Q. Now the contrapositive, we're going to combine both. We're going to exchange and negate. So it's going to be if it is not a mammal, then it is not an elephant. So this one is, if not Q, then not P. All right. So I switched the order. And put the not. Notice that one is true again. So we had true, false, false, true. Okay. So I want you to notice that it's not always going to keep its truth value. Okay. You can give this last one a shot. Okay. I'm going to pass out, give you a practice. Okay. One side is 2.2 and one side is 2.3. Okay. Not on the map. You need a paper. Yep. Dash in this paper. Christian, you get one? It's a paper before you walk out. Make sure you have the practice. You can try it in. Oh, I think I gave you one too many. Those are your notes. You keep them. You can get a folder or a binder or something to keep your stuff in. Remember? Oh, I'm sorry. Remember? Here you go. Well. Okay. Watching this as a video. I just passed out the practice, but I'll go ahead and finish this one. So everybody can check it. So if then statement, we want to come up with the converse, inverse, and contrapositive. So again, if you do not do your homework, that's the hypothesis. And the conclusion is you will fail geometry. Y'all come on in. I'm finishing a recording. Y'all can just ignore me. I'm talking to this video. Yes. Oh, I should. No, take a pause. All right. So I've got my P and my Q. Okay. So then they want us to identify these statements down here as either converse, inverse, or contrapositive. So if I were to switch the order, that's converse. Okay. So remember, converse, you just switch the order. Okay, so the converse would say, if you failed geometry, then you did not do your homework. Okay, so let's see. If you failed geometry, then you did not. That's this one here. So this would be the converse. We just switched the order of the conclusion and then the hypothesis. So switched order, that's converse. Okay, now inverse is the one where we negate. We say not the. It's erasing as I'm writing. Not the. Now, this one is a little different because there's already a not in the original statement says if you do not. So the negation would cancel that not out. So the negation of P would be you do your homework. Okay, and then the negation of you will fail will be you will not fail. So if you do your homework, you will not fail. So if you do your homework, then you will not fail. So there it is down there. That is the negation or the inverse. Okay, because we kept the order of the hypothesis and conclusion, but we said the opposite. Okay. Now this one, the opposite, it had a not to start. So now this one does not have a not. Double negative comes positive. Okay, and so then that leaves, this must be the contrapositive, but we'll double check it. Because remember the contrapositive, you keep the not, but you switch the order. So if not, you not. So if not fail geometry, so if you do not fail geometry, then not. So the opposite. So you do. Oh, so if you don't. I did not, or you don't fail geometry, then you did your homework. Then you do your homework. I did. So that is. Yeah. Order. Failing geometry first. And then so it's when you order is in the queue and it's negated. Opposite of the original statement. On Canvas, if you don't being printed, they can get another. I still have work.